maybe we can start reviewing some of the assignments from last week because there's some big ideas from there I want to talk about. But first, let's talk Boolean expressions. So this helps you with your assignment 4 through a lot of the logic 2 problems in coding bags. Putting them together is the challenge. Most of your learning will occur from those coding bag problems, but just to give you some more vocabulary, more terms to pay attention to, so you can do well on the true and false section on this Friday's quiz. So Boolean expressions. Booleans just means they have values, true or false. It's either on or off, yes or no. Computers like to think 0 and 1, so that's your true and false. This one is the double equal sign. You check to see if things are equal. That's your first comparison. It's called a what operator? These kinds of operators. They are called relational operators, okay? Relational. That's versus logical ones. That's the second set of operators that help you express Boolean logic. So think back to your geometry class. For those that had the luxury of having a teacher that did truth tables, this builds on that knowledge. And it may be a good way to help you organize your ideas for like make bricks, for example, because it's rather complicated. You'll need some tools or structures to help you map out your program. Okay, these are all relational operators. So you have your bang equal, exclamation mark equal, whatever you call it, right? That's not equal to. You have your greater than, your less than, greater than equal to, less than equal to. So you'll often use a lot of these symbols when, like, in your Logic 2 assignments in any kind of your code. And they are what you think it is. These, for the most part, if you're switching between languages, are like normalized. It looks like this. This one can be represented in different ways, okay? Not equal. The other ones, right, that are important are logical operators. This is and, or, and not, okay? You can implement if-thens just using ands, ors, and nots. These are the bases, okay? If you study computers down to the architecture level and you think about circuits, they have something called AND gates, OR gates, and NOT gates, right? And if you break down a computer, that's all that it's built out of, these ANDs, ORs, and NOTs. We're doing the software component of this as we're putting together expressions, right? Like 2 mod, or n mod 2 equals 0, so it's divided by 2, or it's divisible by 3, right? When we talk as humans, the English language, most of the time matches what we think about and, or, and not, right? Not true is false. Not false is true. And it's the ands and ors that you play with more to get more complicated rules. You go to the restaurant, right? My professor in college always mentions this, right? Do you want the soup or the salad? Yes? And then you say both, correct? Computer scientists later will say, yes, of course, right? But of course, they're not usually attuned to that, right? Usually it's just pick one. So when we talk, that's the exclusive or, right? You are not allowed to choose both options. Just remember the or in computer science, both of these can be true, like a number can be divisible by 2 and divisible by 3, and it causes this whole overall compounded Boolean expression to be true, right? Like the number 6, right? That satisfies both. And ands, both of them have to be true. Where's my example, right? You have to be greater than 0 and less than 10. Satisfying one of those won't cut it, right? If both of these are false, then it's fine. You won't move on. A number like 9, for example, will work. Yes? Nots. It's hard to find an interesting place to use the not operator. It kind of flips your logic. It's kind of like that if-else relationship. As you practice more and more, you'll see that this is actually more handy than it is initially. But I'm not quite sure how to describe it. And when it comes up, I'll point it out. But most of your problems, you'll use ors and ands, okay? So vocabulary, logicals are and, ors, and nots. Vocabulary for here, right? The relational operators, that's not equal, less than, greater than. So we're on to this side. How does this all fit into making us like better programmers? So Boolean logic and this selection, conditionally running code, like what triggers one line of code versus another, that's why we have these things. If statements, along with else if statements and else statements, okay? This is where Python's kind of weird. Elif is else if. Only one of these can run at a time, okay? And that's the part that you have to get used to. Right now, like when you start out in the beginning, like in computer programming A, you just did a bunch of these all together. As you get more complicated problems, your logic may build upon each other. It's either this or this one, and else is your catch-all. If none of the above is satisfied, then the else runs. Otherwise, if you hear those using those words, it's the else. And there's no limit to the number of if statements you can have. There is a limit in one block like this, an if block or a conditional block. There is a limit to how many ifs you can have and how many elses you can have. You can have at most one else. That means you can have one or none. You can have an unlimited amount of elifs, right? And it's like you can have none too. And to get an if statement, well, you can just have one of those in a certain block. That's not to say you can have separate blocks with like if, so on and so forth, right? But that's different kinds of logic. Okay, notice I mentioned before you can put if statements inside of if statements. Notice over here that is boxed, it's the same program I had before. And then here implements that same kind of logic. And visually you can see, like this one's a bit easier to read, right? You have case 1, case 2, then the catch-all. This one, sometimes you'll want to do nested. This may speak to you first. But notice it's a bit harder to follow. You lose some of the meaning there that the else if captured, right? If they're equal, that's great. But now the else became way more complicated. Okay, so they're not equal and they are less than, x is less than y. I have to remember this else stands for, okay, so they're not equal and x is greater than y, right? I had to do a bit more thinking there. So there is some preference, right? Although these two produce the same output, to want to think this way, right? Someone else is reading your code. Now, that's not to say when you're writing your program and the audience is just you and me, you get the job done like so, right? Right now, the audience for our code is me and you. Later, you want to do things like this. As you work with more people, you think about who is your code serving. Is that what I talk about? I think that's what I say in the words there. What I don't like about using slides is my intelligence has been insulted before. Where I go to a presentation and teachers often do this. It's like, I'm going to read to you every single word on my slide, right? Word for word. I'm like, no, I can do that on my own. Please don't bore me like that. And so it's part of the reason why I've been so negligent on making slides, because I don't want to find myself falling into that pattern. Yes? No? You understand? Partially, yeah. So that's why you won't see me using a lot of the words there. Hopefully they serve more as notes to you, and you're listening to me talking right now. Those in computer programming. So if statements with inside if statements. That's the new idea of this next series of slides, right? Notice this one, logic-wise, if inside an if, that's great. And you kind of saw me already compounding them together using those logical operators, right? In one line, you've accomplished this kind of reasoning, and based on how I'm talking in the English language, this could speak to you, right? In math class, it looks more like x is in the middle, and you go like this. You're already used to seeing that expression, and implement that in computer code. Use the AND, logical operator. So far, so good? Yeah. So that's all for part 1 of the lecture. I hope to demonstrate, today I want to review some key ideas from your last assignment, Computer Programming B. Make grid, some of those problems, some ideas that I hope you notice. So I'm going to pause it.